Hi, I'm Taesung Hwang from Wisner Incorporation in South Korea, and I'm so glad to have a chance to introduce our work in Interspeech 2020. Our work is about multi-turn response selection in retrieval-based dialog systems, and the title is An Effective Domain-Adaptive Post-Training Method for BERT in Response Selection. This work is collaborated with Dong-Hyuk Lee from Kakao Corporation, Chani Lee, Gi-Soo-yang, Dong-Seok Oh, and Professor Hee-Sung Lim from Korea University in South Korea. Before I explain about our work, I would like to introduce what the multi-turn response selection is and how it works. Suppose that there is a dialogue context between a student and a course advisor. The student wants to get some advice to choose courses that he should take in the next semester. The last utterance is spoken by the student, and he said that he is interested in computer science and video game design. Given this dialogue, the dialogue agent is required to respond to the last utterance. So in the retrieval-based dialogue systems, the dialogue agent first searches some relevant responses by using search algorithms, and then select the most likely response from the selected candidates. Here, the answer will be the first one because the advisor recommends a course related to the computer science and video game design. So the objective is predicting the most consistent responses following utterance. In the previous research, jury encoder with RNN and LSTM-based model were proposed by Low et al. 2015. Generally, the triplet, which consists of dialog context and potential response and its label, is fed into the model, and the model is trained with the pointwise method. The model architecture is based on recurrent neural network. Simply calculate the relevance score between the dialog context and the response, and the model is optimized with the cross-entropy rules. For the last few years, many researchers mainly utilize attention-based matching networks. All these methods focus on building task-specific models. However, recently, pre-trained language models such as BERT, XLNet, and Electra have shown great performance improvement in various natural language processing tasks compared to the each task-specific models. Therefore, we also adopt the contextual language model, specifically BERT, in this work. Here are the motivation of our work. Despite the huge success of contextualized language models such as BERT and XLNet, they still have limitations to represent contextual information in dialog corpus, specifically domain-specific corpus. Some dialog corpus, such as Ubuntu corpus, is biased towards a certain domain. Pre-trained contextual language models are not able to fully represent dialog context. In the response selection task, Chaudhary et al. 2018 showed domain understandable embeddings constructed from external knowledge. For example, Ubuntu manual description is highly effective for corpus understanding. So in this paper, we propose an effective post-training method using BERT for a multi-turn conversational system. By conducting masked language model and extent prediction during the post-training period, the model is able to fully understand colloquial expressions as well as domain-specific context. We also append a new special token, EOT, which is end of turn token, to the end of utterance so that model can learn relationships between utterances during the period of post-training. To the best of our knowledge, it is the first attempt to adapt BERT on the most popular response selection benchmark dataset, Ubuntu Corpus version 1, and we also obtain new state-of-the-art performance on two benchmarks, which are Ubuntu Corpus and Advising Corpus. Since contextual language models are pre-trained on general corpora, such as the Toronto Brooks corpus and Wikipedia, it is less effective to directly fine-tune these models on downstream tasks if there is a domain shift. Hence, further training such models with the language modeling objective using text from the target domain reduces the negative impact. The model is trained with two objectives, mask language model and next sentence prediction. Mask language model helps the model understand domain-specific corpus, and next sentence prediction has the effect of data augmentation. In the example of mask language model can learn the sudo command is needed when trying apt insert in Ubuntu system, which is not generally showed in universal corpora. Unlike general sentence, multi-turn dialog system is composed of a set of utterances. Therefore, we add a new special token end of turn token and append it to the end of each utterance to let the model catch each utterance is finished at the point. To fine-tune BERT for response selection, a point-wise approach is used to learn a cross-encoder that receives both dialog context and response simultaneously. Each utterance UT and response RT are composed of multiple word tokens, including a special end of turn token EOT at the end of each utterance. Input sequence X is fed into the pre-trained BERT model, then output representation of CLS token TCLS is utilized to classify whether dialog response pair is consistent or not. A relevant score of the dialog utterances and response is calculated by using one-layer feed-forward neural network, and we use binary cross-entropy loss to optimize the models. We evaluate our model on two multi-turn dyadic datasets, Ubuntu IRC corpus and Advising corpus. For the Ubuntu corpus, training set is composed of $500,000 context containing positive and negative responses with the same ratio. Each validation and test set contains $15,000 context with 1 positive response and 9 negative responses. Advising corpus consists of $100,000 for training set and $500 for validation and test set. All datasets contain 1 positive response and 99 negative responses. We only use 1 negative sample for training to make same conditions with Ubuntu Corpus. As evaluation metrics, we use 1 in n required k, where n is 10 for Ubuntu and 100 for Advising Corpus, and we also utilize mean reciprocal rank to evaluate our model. Generally, we evaluate our 4 BERT-based models. The first one is BERT-based models, which is a vanilla BERT-based model for response selection task. On-case BERT-based model checkpoint is utilized as the initial weights of the model, and single-layer perceptron are trained during the fine-tuning phase. BERT DPT is a BERT-based model that is post-trained on domain-specific corpus. So mask language model and NLP tasks are conducted during DPT phase. BERT BFT is a model that selects the number of top layers to fine-tuning in BERT DPT. So, for example, when T is 12, all the BERT DPT layers are fine-tuned, and T is 0. When T is 0, only embedding layers are fine-tuned. Lastly, BERT BFT performs data augmentation technique by increasing the number of negative samples. The number of negative samples are decided by several experiments. So when the number is 4 shows the best results. So we picked 4. Negative responses are randomly resampled for every epoch from response candidates pool. So in Ubuntu Corpus version 1, post-training BERT shows its effectiveness that outperforms 3.4% on record 10 at 1 compared to the BERT-based model. Domain-specific corpus optimized BERT VFT model shows performance improvement by 8.8% on record 10 at 1 compared to the general transformer model, DEM. For advising corpus, we compare our approach with 2 existing baselines proposed by Big and Remia and Chen et al. In the STC7. The former baseline evaluates BERT-based model on the advising corpus, but there is substantial performance difference from what we obtain. We believe that different implementation frameworks and hyperparameters, such as learning rate, are the main reason why performance differences exist between our work and that of Big and Remia. The first place of the challenge was the work conducted by Chen et al. BERT VFT outperforms 6% in terms of record 10 at 1. Domain post-training shows its effectiveness on advisory corpus as well, leading 3.4% higher results in terms of record 10 at 1 compared to the BERT baseline. We also conduct an experiment bearing top few layers, which is fine-tuned during the period of training. The models achieve the best performance when t equals 4 and t equals 6 for Ubuntu and advising, respectively. We conducted an evaluation study by removing each test of BERT, regardless of using EOT token. Using both objective functions shows the best results. Appending the new special token EOT to the end of each utterance shows absolute improvement by 1.2% in record at 1. In conclusion, we propose a highly effective post-training method for BERT in multi-turn response selection. Our method outperformed previous state-of-the-art methods on 2 response selection benchmarks, Ubuntu Corpus version 1 and advising corpus. For the future work, we will utilize external domain knowledge, such as Ubuntu manual description in Ubuntu Corpus, or curriculum information in advising corpus to enhance the domain understandings. Thank you for listening, and our code and data is available in the GitHub website. So thank you for listening.